Okay, so we have one video to get through here about picking cards from standard deck. So in the first case here, we have how many different four card hands could you create, having one from each suit. So that just means it's going to be 13 choose 1 times 13 choose 1 times 13 choose 1 times 13 choose 1. And we don't really have to worry about this beyond that because because we're only picking four cards. So this is actually probably one of the simpler questions you'll encounter um, because remember there's 13 of each suit and we're going to choose one from each suit. So it's just 13 to the 4. Just 28,568. Sorry, 28,561. Um, that's A. Okay, for B, they say how many different five card hands could we have with at least one spade? Okay, so what I'm going to do is I'm going to recommend you do the indirect method. Okay, how this works here is you're going to take the total um, five card hands, and you're going to subtract the number of five card hands with no spades, right? Because if we take the total five card hands and we subtract the number with no spades, then that guarantees us that we're going to have the number with at least one spade. Okay, so how do we do that? It's actually not too bad. This is just going to equal 52 choose 5, because that's the total number of way to pick um, uh, five a five card hand from 52 cards, and then the total number of five card hands with no spades. So there's 13 spades. We're going to choose none of them, and then times 39 remaining cards, choose five of them. Okay, and then if you work that out on your calculator here, um, see if I can find my data numbers. Okay, so 52 minus. And you don't have to actually write the 13 choose 0 part. Okay, I just got a number here. Um, I got just trying to copy and paste from my calculator. It didn't work. So it's what's that? 2,000,000 comma 023 comma 203. Okay, and that was B, by the way. I think that it just arbitrarily changed that on me. Okay. So lastly, they want to know how many different five card hands could have at least two face cards. Ugh, okay, so this one here is going to be kind of annoying. Um, there's two ways to do this. You could do this directly. The number of cards with five card hands that have 2, 3, 4, or 5. Or you could do the indirect, which is the number of five card hands. Then we subtract the number with no faces. We subtract the number with one face. And then we subtract the number with no, that's all we'd have to do because at least two faces. So two faces would be included in our answer. So we're subtracting what's not in our answer because we're taking we're doing the indirect method. We're actually solving for the opposite of what we want. So we take the total number of five card hands and then we subtract the two cases that would not be included in the set of five card hands with at least two face cards. So that would be no face cards or one face card. So it's actually pretty simple here. We go 52, choose 5 because that's the total number of five card hands. And then we'll subtract the number with 0 faces. So that would be, there's 12 face cards, right? Because there's 4 of each suit. There's a Jack, Queen, King. So 12, choose 0 times. There's 40 cards remaining that aren't face cards. Choose 5. And then minus 12, choose 1 times 40, choose 4. And then you just work that out. Um, Okay, just give me a second here. I'm going to just do this all in one shot here. So 52 choose 5 minus, you can do 40 choose 5. You don't have to do the 12 choose 0 part because it's just 1. And then minus 12 choose 1 is a thing. You have to deal with that. It's just 12. There's 12 ways to choose one thing. And then times, and then I wound up with the number here of 844,272. And that's all there is to it. All right, so I hope that this made some sense for everyone. Um, um, it's these questions here, I promise you that once you do enough of them, it actually gets quite simple, but it can be a little bit confusing the first couple times around. And that's pretty much it. All right, thanks.